Good evening, grade 7. I hope everything is okay with you and your family. Our lesson today is about the sound waves and hearing. Okay, so open page 38 with me. So a sound, it's a kind of waves. And we said before that we have two kinds of waves, longitudinal wave and the transverse wave. What is the difference between longitudinal wave and the transverse wave? A longitudinal wave, like here, it's a kind of vibration. Okay, so it's a compression and rarefaction. What is the difference between compression and rarefaction? A compression, it's when the particles are so close together, and rarefaction when the particles is spread apart. So again, what about the longitudinal wave? Longitudinal wave, it's a kind of compression and rarefaction. Compression and rarefaction. What about the compression? When the particles are so close together. What about the rarefaction? When the particles is spread apart from each other. Okay, so we said before that longitudinal wave travels as the direction of the disturbance. Disturbance, yes, and we said before that the wave is a disturbance to transfer what? Yeah, to transfer energy. Disturbance to transfer energy. Disturbance to transfer energy. So it's a longitudinal wave. Longitudinal wave, it's a kind of compression and rarefaction. Compression and rarefaction. Compression when the particles are so close together. Rarefaction when the particles is spread apart. So what is the sound? It's a kind of vibration. What about the vibration? It's a back and forth of motion. It's a back and forth of motion. So what are sound waves? It's a kind of longitudinal wave when the particles are spread apart in the rarefaction and compressed in the compression. Miss, we said before that we have another kind of waves, which are transverse wave, Yes, what about that transverse wave? When the particles moves up and down, or crests and troughs. So here in this diagram, what about here? When the particles are so close together, so this is compression. What about here? When the particles are far from each other, this is rarefaction. Okay, so again, what about the sound? The sound, it's a kind of vibration. The sound, it's a kind of vibration. So it's the complete back and forth motion of the object. Complete back and forth motion of the object. And it's a kind of longitudinal wave. Longitudinal wave. So what about a mass? Longitudinal wave, it's a kind of compression and rarefaction. Compression and rarefaction. When the particles are so close together, it's the compression. When the particles are far or spread apart from each other, it's the rarefaction. We can see video about the movement of the longitudinal wave like here. Okay. So do you see the vibration of the particles? Do you see? So this is the wave motion. Do you see the vibration? So when the particles are so close together, it's the compression. When the particles spread apart, this is the rarefaction. So the sound, it's a kind of energy that transfer from a place to another place as longitudinal wave. Again, as longitudinal wave. Do you see when you beat the drum? Okay, so there is a vibration in the medium. And we said before that the sound is a kind of mechanical wave. What does it mean by mechanical wave? Yeah, that's it. It's a wave that needs medium to travel. It's a wave that needs medium to travel. And here, do you see the transverse wave? Transverse wave, it's ups and downs, crests and troughs. So how do sounds wave travel through a medium, here. Through a medium, why, miss? Because it's just a vibration in the medium. So it needs a material to travel through, like solids, liquids, and gases. To vibrate through it. So we can see another video about how the sound travel through different materials, different solid, liquid, and gas. Okay, do you think, is it faster in the solid, liquid, or gas? The vibration of the particles, yeah, it's very fast through the solids. Why? Because the particles are tied together, or the particles are too close together. Sorry. Okay, so do you see the particles here in the solids? Yeah, here the particles are so tight. Do you see this compression and rarefaction? Do you see the movement of the longitudinal wave? Yeah, that's it. So it's very fast in the solids. Why? Because the particles are so tight together or very close together. That's in the solid. Do you see